talks about like what happened and why, what changed. I'm not going to talk about these things. I'm just showing an example. This is what happened. At a high level, this is what happened. The first one is, remember we did this back propagation where we went from one end to other end of it, right? And we're doing this for supervised learning data, where we have the data for it and we have the labels for it, and we're going back and forth, right? But what happens generally is, if we have a lot of text, now don't worry about the text, we have pictures for it that explains it, but at a high level, conceptually, instead of going from supervised learning data, we just want to learn the patterns that you have. If let's say you have like 1 million documents, forget about which category they belong to, right? Just see if there are patterns within the data. Do that first, right? So that's one key thing. Right? The second one is, you know how we were going from one layer to the second layer to the third layer? Instead of doing that, just within one layer, go back and forth and see, maybe you learn some patterns with it. Right? And the third one, which kind of got cut off, this is what happened if you do presentation in Windows and present on Ubuntu. So what happened was, finally, you still do the backward propagation, right? But you do it at the last. So you keep on doing the first and second step for a long time, and then do the third step. And that was like a major break. It's a very simple thing, but it created like this. No, it actually works.
So does this mean that the neural network guys were just holding the incantation book upside down?
Yeah, almost like that. Yeah. So this is what happens, right? So we have, and there are different kinds of algorithms. So I just want to give some background. So one is called autoencoders. It's similar to logistic regression. So this is like a well-known machine learning technique. It's simple to understand, easy to implement. So we talk about how it is done to autoencoders in the coming slides. And there's one more technique called restricted Boltzmann machines. So if there are any physicists in the crowd, it's basically based on energy models. And we use the different training techniques. I'm not going to talk about restricted Boltzmann machines here because, mainly because, well, two things. I wasn't sure if I explained a lot of math on the thing. I don't know if anybody will yawn or don't understand what's going on. I just want to give a high-level conceptual overview now. And if people are interested in more details, we can do like a deep learning like a tool, and we can talk about it more in detail. So we're not talking about Boltzmann machines, RBMs in general. But in practice, both of them seem to work really well. They have their own advantages and disadvantages. But I like autoencoders because it's easy to understand.